Hi guys, today's subject is digital system processing. The topic is classification of signals. Introduction to signal classification. Signals are fundamental in various fields such as telecommunication, electronics and control systems. Understanding how to classify the signals helps in analyzing and processing them effectively. This presentation will explore different types of signals and their classification. For example, in this figure, if an unknown signal RF signal is passed, the modulation classification will be given into 5 types: BPSK, QPSK, FSK, 16QAM and 64QAM. What is a signal? A signal is a function that conveys information about a phenomenon. Signals can represent physical quantities such as voltage or current over time. They can take various forms including analog and digital representations. Signal. A signal is defined as a function of one or more variables which conveys information on the nature of a physical phenomenon. Value of the function can be real valued scalar quantity, a complex valued quantity, or perhaps a vector. System. A system is defined as an entity that manipulates one or more signals to accomplish a function, thereby yielding new signals. Types of signals. Signals can be broadly classified into continuous and discrete signals. Continuous signals have values defined for every instant in time. Discrete signals are defined only at distinct intervals or sample points. Continuous or versus discrete signal. Continuous signals can be represented mathematically as function of time. Discrete signals are often obtained by sampling continuous signals at the specific intervals. Classification impacts how signals are processed and analyzed. Analog signals. Analog signals are continuous in both time and amplitude. They can take on any value within a given range, representing real-world phenomenon. Common examples include audio signals and radio waves. Digital signals. Digital signals represent information in binary form using discrete values. They are less susceptible to noise and can be easily processed by digital systems. Digital signals are essential for modern computing and telecommunications. Deterministic versus random signals. Deterministic signals can be precisely described as mathematical functions. Random signals exhibit variability and cannot be predicted with certainty. Understanding the nature of signals is crucial for effective analysis. Periodic versus aperiodic signals. Periodic signals repeat at regular intervals over time. Aperiodic signals lack a repetitive structure and vary in duration. Periodicity of a signal influences its frequency components. Energy and power signals. Energy signals have finite energy and zero average power over time. Power signals have finite power and may not have finite energy. Classification into energy and power signal aids in understanding their behavior. Continuous time versus discrete time signals. Continuous time signals are defined for every value of time. Discrete time signals are only defined at discrete intervals of time. The distinction is essential for signal processing techniques. Even and odd signals. Even signals are systematic around vertical axis in their graphical representation. Odd signals exhibit symmetry about the origin. These classifications can help in analyzing signal properties and behaviors. Causal and non-causal signal. Causal signals depend on present and past value but not on future values. Non-causal signals include future values in their definition. This classification is significant for real-time processing applications. Systematic classification of the signals. Signals can also be classified based on their characteristics and example applications. Common classification includes audio, video, image, and control signals. Each type of signal has unique processing requirements and techniques. For example, signals can be even compared with classification of animals as vertebrates and invertebrates. Classification in telecommunication. In telecommunication, signals are classified based on modulation techniques. Common modulation methods include amplitude modulation and frequency modulation. Understanding this classification is crucial for effective signal transmission. Types of modulation. It can be classified into continuous wave modulation and pulse modulation. In continuous wave modulation, it is amplitude modulation and angle modulation. Further, angle modulation is divided into frequency modulation and phase modulation. In pulse modulation, it can be divided into analog modulation and digital modulation. Under analog modulation, we have PAM, PWM, and PPM. Under digital modulation, we have pulse code modulation, delta modulation. Application of signal classification. Signal classification plays a vital role in applications including filtering and compressions. It aids and designs of the communication system and signal processing algorithms. Accurate classification leads to improved system performance and reliability. Signal can be classified into linear and nonlinear. In linear, it is stationary and non-stationary. Stationary is divided into Fourier transform and non-stationary is divided into wavelet transform basis. Signal processing techniques. Various techniques are employed for processing different types of signals. Techniques include Fourier transform, filtering, and sampling. Each method is tailored to the signal type for optimal performance. Challenges in signal classification. Noise and interference can complicate the signal classification. The presence of nonlinearities may also affect the classification process. Advanced techniques are often required to overcome these challenges. Future trends in signal classification. Emerging technologies as machine learning are enhancing signal classification methods. Real-time processing and analysis are becoming increasingly important. Future advancement will likely focus on improving the accuracy and the efficiency. Conclusion. Signal classification is a key aspect of signal processing and analysis. Understanding the types and characteristics of the signals enables the effective communication. Ongoing research and development will continue to advance this field. Thank you.